Let's continue our discussion of thermodynamics now. Now that you have an understanding of heat flow, we're going to get into the ways that we can describe heat flow. So we'll talk about endothermic and exothermic processes. So to begin, heat flow is able to be described based on the direction that it travels. Okay, so the direction that it travels in relation to a substance. If heat flows into a substance, we call this an endothermic or a heat entering process. Okay, so if, for example, let's say you were given, God, what's a good endothermic process? Okay, so I'm going to melt something. Okay, let's say I have, here is an ice cream cone, and this is solid ice cream. Okay, well, in order for this ice cream to melt, what has to happen is heat has to enter. Okay, this ice cream is going to have to take in heat in order for the process to cause it to melt. Okay, so if heat flows into a substance, we say this is endothermic. If heat flows out of a substance, then our description is exothermic or heat exiting. Okay, so an example of an exothermic process would be, you light a candle, and above that candle, the flame that you have is going to be giving off heat. Okay, so relative to the substance, right? So the candle, the wick, right? These are going to have a combustion reaction, and it's going to give off heat. So both physical and chemical changes can be described in terms of heat flow. So both of the examples this example that I gave is a physical change. In the candle burning, this is a chemical change. Okay, but either could be described in terms of heat flow. Now, another example of an exothermic reaction would be combustion of hydrogen. Okay, so I showed you the candle before. The same thing could happen here. If I have hydrogen gas, so that's H2 gas, when that combines with oxygen, O2 gas, in a burning reaction, it's going to form H2O gas. And if we're going to balance this, we know that we're going to have two H2s and two H2Os. So let's say that this combustion takes place. What we're going to see here is that my reactants, right, this is the starting portion in this, when they come together, when they form this product, they're going to also release heat. So a way that we could describe this is it is this plus heat. Okay, so that is exothermic. So the substance loses energy and the surroundings will gain energy. So what I want you to think about is this. If my burning, okay, so here is my flame, the combustion of my hydrogen gas happens here. So this is the substance, and then outside the substance you have the surroundings. The substance is going to lose energy and the surroundings will gain energy. So the flow goes from the substance to the surroundings in this exothermic process. Now, if we want to take this a step further and think about it as part of the surroundings, a thermometer, right? So if the surroundings, if there was a thermometer in the surroundings, what would register is that the thermometer is going to gain energy, so its temperature will go up. If your hand, if you were trying to touch this, right, here's your hand. Hope you like my beautiful hand drawing. If you put your hand up to this, right, it's going to be giving energy to your hand, right? And so the temperature of your hand, the energy of your hand goes up. The thing to keep in mind here is that exothermic processes will feel hot, okay? A relative term, right? That's not specific, but they're going to feel hot even though the substance is actually cooling down. Because while the surroundings gain temperature, this must be losing temperature in this process. So now let's consider again the ice cream example, this endothermic physical change. Now in this case, so we have our ice cream cone. the substance gains energy and the surroundings lose energy. So the ice cream here is the substance, and then I have my surroundings. What has to happen is the ice cream is going to absorb energy from the surroundings. So the surroundings, if you think of it in these terms, right? If the surroundings were a thermometer, the thermometer temperature will go down as it loses energy. The substance, the ice cream in this case, is going to have a temperature increase. If your hand, again, you put your hand up to this, almost as bad a hand, almost. It would take energy from your hand to go into this ice cream in order to melt the ice cream. So similarly, an endothermic process feels cold, even though the substance is actually heating up. Okay, so just keep that in mind. Now, I'm going to go ahead and let you work on these. I'm going to pause this and then resume it in just a sec as a second clip.